Hi, I'm Andy. I work for a company called Contentful. We do some content hosting for you and present it to you as an API. It's quite nice. I'm also known as Pixelpunk on Twitter and GitHub. You can follow me there. You can stalk me there. You can fork my projects and commit to them. Would be awesome because they have a few bugs. You might recognize me from the picture. I don't know who picked that, but thank you very much. So, we're talking today about Docker, the shipping, another ship reference, sorry. The thing is, what is this whole talk about? So we go a little bit through a theory, have a little bit of technology, have a tiny demo, have a little more demo. There will be no cats. There will also be no CSS, HTML, JavaScript, or other front-end stuff. This is a dry back-end talk with a little bit of code. So what is Docker in theory? I don't see my speaker notes, or whatever. So Docker is an open source engine that basically allows you to pack your stuff, your application, your tools that you created in a container and ship it literally everywhere. You can move it from one server to another, can create updates, push it out there. It was intentionally created by .cloud. They got asked, so what are you using to host all this content and this stuff that you have there? And they said, yeah, well, it's a wild mixture of things that we created, and then they thought, well, we could rewrite it, make it better, and then give it back to the community. So they started using Golang to create a completely new project called Docker. The main features of Docker are, as I said, you can literally encapsulate any kind of payload that you have. And by payload, I mean your app, your PHP, your Ruby, your Python, if you write it in Haskell, go for it, you can ship it. The cool thing is, you only pack in the dependencies that you have. So if you have app A needs library B in version 1, and app B needs library, the same library in version 2, you have a conflict. And so you just ship the libraries and the tools and your dependencies that you need within your app, nothing else. It's super lightweight. It has no, literally or virtually, no performance penalty when you start it. You start a container and it's there, and then the app starts immediately. You can shut them down, you can move them to a different server, you can move them to a different country, you can move them to your USB stick, bring them home to your offline computer, start them up there, and use your app there. And you can also manipulate it. It works a little bit like Git, where you have every stage where you add something to your container, it gets committed, and you can always revert to these things. And then you can build up your container step by step. It's like stacking up slices of bread to make a very nice and awesome sandwich. I like food. So it also helps you to separate your duties. Usually you have your application that is nicely written, engineered, and well-tested and everything. And then you have your infrastructure. And you always then have to mess with the infrastructure when you want to deploy some new code because you need a new feature. And you always have to do a manual approach on this. You can either use automative tools like a Chef and Puppet that help you to automate it, but they're kind of confusing sometimes, and you need to learn a new language to get your code somewhere there with your dependencies and all your... This is a fucking mess. And here it's just separated. You write a simple script that creates your container, and then you have your app, you stuff it in, you ship it. Also, it nicely takes care of your network resources, of your resources in general, your CPU, your memory, and also helps you to say this container only is allowed to have this amount of memory, and it doesn't get more. So one app cannot go wild and eat up all your CPU power, your memory, and then crash, and you have a downtime, and you get woken up at 3 in the morning after you were at the party because your service is down again. Pardon? When you're still at the party. Or when you're still at the party, even worse, because then you don't have internet, or you have to place your beer somewhere while you have to code. Never put your beer on your notebook. Bad idea. So what is the difference between a container and the classic definition of a virtual machine? A virtual machine consists of, you have your operating system, then you have your hypervisor on top of it, then you have your virtual machines, then you have another operation system in it, then you have all your dependencies, your libraries, your tools that you need, and then on top of it, you stack your app. So you need to build literally a Mount Everest to get to the point where you can actually run it and present it to users out there. In the Docker world, it all runs a little bit different. It's almost the same until your virtualization or hypervisor, and there you set in your Docker, And you install your libraries. And Docker containers can share your dependencies with each other, only if it's necessary and only if it's wanted. And then on top of that, you put up your app, and then you want to have the same app again, you just take the image, clone it, and you have another app. Or you just put up a fresh container. In the next way, you can just take your app that you have now, modify it a little bit, create a new container out of it, and you can run both in parallel. You can do A/B testing, but just creating new virtual machines in a way. So you don't have to do any kind of weird flags or other stuff, and the front end is all nice. Container, it's like you can imagine. You have this, for example, in Rotterdam, you have this huge container harbor. And they have these things where you go down, grab a container, and move it somewhere else, drop it again, put it on a ship, ship it. It uses basically a Linux lightweight container. They are not so new, but pretty cool technology. Or actually, they are quite new, but this recently released the stable version of it. It uses C groups to actually take care of your resources, of your CPU, of your memory, and the Linux kernel itself. So if you want to use it, you have to use Linux and now a Mac. Windows is a little bit unsupported, basically not at all. So how is the life cycle or the basic function of a container look like? You build a container from a Docker file. You modify it then, so you add your content to it, your application again. You can also just add a service like Redis to it or a database, which I would not recommend, but it's possible. You publish it to a so-called registry, which is a package management system in a way for your containers. And then you just pull your containers on your servers that you wanted to, run them, start them up, and they're live. You can always push new versions out of there. You can delete stuff. It's still all a little bit in the running and in the go, but it's getting better. Now we have our very first little demo here. It's super simple. And it's just to explain you a little bit what's happening in the Docker world. So in Docker, you create images, and from these images then, you create containers, and these containers actually run then. So we have here our nice example. That was already the example. So what happened here is pretty amazing. We took an image, we created a container, we initialized the file system in it, we created the whole network stack around it, we booted it up, we started the echo command, printed out hello world, we destroyed the container again, and we're done in a matter of no time. It's so fast. So how fast is it? Incredibly fast. So this is basically how it works. You start up your app and it's running, and you see there's not really an overhead. If you run echo like this it doesn't really take much longer. But I don't really have to set up the whole network and stuff like this. So, next. Am I too fast? Or we just make it shorter and then we can go have a longer break. What are use cases for Docker? I already presented a few. Well, it's mostly about shipping. So this is where all the shipping and ships and piratey things come from. You can basically, I should stop saying basically also. You automate your whole deployment of your app. You script the hell out of it. You don't want to touch it anymore. You don't want to run manual install commands on your servers. Just put everything in containers and ship it out. You can also create your own private platform as a service. So your mini Heroku, your mini Any9s, in your own infrastructure, and this is actually what's already happening out there. Companies are creating their internal infrastructures on Docker and just ship always container and don't really have to do any Git checkouts anymore manually somewhere, restart the app and stuff like this. You can also stuff your whole, if you do automated testing, which every single one of you should do, all the time, never write a line of code that is not tested. It will blow up, you will hate it. There is a new project, it's Drone, which helps you to run locally your test, and you just need the dependencies you need for it, stuff it in there, run your test, everything is green, fine, ship it. I should go into the shipping industry. And you can also deploy your apps, of course, and you can scale them. So if you, for example, have a worker somewhere running and it's taking long and long and long, and you have multiple requests coming in to do this work, you just add another container and you have 2 containers then working on it, or 3 or 4 or 5, and you can virtually run hundreds and thousands of containers in parallel. It's not a problem. It's a super thin layer. You don't have any problems there. There are a few companies out there who already use Docker. As I said, it's quite beta. They're not stable yet. There's a lot of change going on. They made a lot of progress. The project is now a year old, and they achieved a lot out there. You have companies like Blitline, eBay, Flynn.io, which offers an open source platform as a service. You have Yandex, who created Cocaine, their own platform as a service in it. You have Worker, who is an automated continuous integration system. You have Cloudflare, Travis CI, who also everyone should love, uses it and makes it possible for you to create your own build packs. And you have Rackspace. And there's also, if some people use OpenStack, you can also have adapters for that to remote control your cloud from your OpenStack installation. Now we're going to have some code. So to create a container or an image, to create an image to actually launch a container, you need a little bit of help. And sometimes you script it, but Docker decided to make their own language to do this, and it's super simple. This is the most basic example that you can have to get an up and running container. So in the first line, you have from. This means this is our base image. We create this image now from our Ubuntu 12.10. Sorry. You can also create your own base images. And you can also, for example, create an image and then on top of that create more images, and then spread it out like the snowball system. You can run commands when the image gets created. The cool thing is every run command does a commit. So if you run your commands and then it fails, the next time you try it, when you change something, it will run off the point where it last time could commit. So you save time. You don't always have to set up the complete server again and again and again, which is time consuming, and you can get more stuff done. The lunch break is, that time is over then a little bit, I'm sorry. And then at the end, you define an entry point, and this is when you create a container and you launch it. This is then what gets started. So in this case, I just use bin bash, but usually you use then the executing function of your application. You use your rackup, you start your Rails, you start your PHP, Python, Django, whatever. Everything that can fit somehow into a VM can fit into a Docker container. Now we get to the app. I created a little super easy, straightforward application to show a little bit of what Docker is able to do. The app is super simple, as I said. It's a web service in Sinatra where you make a web request, you give it a job and a cost, how much it will take to process this job. And then you have a worker container who is then actually processing the job and working like crazy. And you have to exchange, I abused here a little bit, Redis as a queuing system. Usually you can also use RabbitMQ or whatever is out there. There's so much awesome stuff. The web app is rather simple. So here is the GET request. We take a task, we take a cost, we tell the worker, do this asynchronously. This puts it into the Redis. The worker then fetches it from Redis, and there's no direct connection between them. And we are only going to use containers. This is the worker. It's a simple worker. It's cute. It's just going to tell you what it's doing, and then it's sleeping for this time because it's a lazy worker. So this is all super boring stuff. The fun part comes here. This bold DB port 3678 TCP adder. It's awful, but this is auto-generated by Docker. And what you can do is you can tell Docker, take this container, and I want to have those two linked over the network. And Docker then automatically exposes these variables for you, and you can use them in your application. So you don't even have to do this manually anymore. You just boot up a container, say, this and two, connected, be friends, go. And ship it. Then the rest is just even more boring configuration stuff that no one cares about. Let's get our hands dirty. I prepared something here because it's not only about shipping, it's also a little bit about cooking. Or it's a little bit like a cooking show. So let's get started. What do we have here? So I created these funky little things. Because I'm a lazy guy, I'm a programmer, I create and automate everything. So I have a build script that is just creating my containers. That's not very good to see on this side, huh? So, better? Yes. What's happening here is, these are the Docker files. And they define how my containers look like. And then I give them a name, a tag. This is Redis. And then tell Docker, build it. And it creates for me the whole infrastructure in it, creates all the file system definitions in it, and places it into my local registry. These Docker files look super simple. So I have a base file to define everything that I need. This is all the commands that I run to install my stuff, have fun with it. Ruby has one or another dependency. All of this is also on GitHub. Because I actually planned to bring a laser sword with an LED pointer in it, but I forgot it, I'm sorry. Which button do I press? Cool. So this is just, and here again, every run gets into a commit, and you can start from there all over again. And this is my basic tool that I use. I then created the actual app on top of it. Hoppala, we don't want to do that. Gesundheit. So, this is our web app. It's extremely simple. Oh, sorry. It's extremely simple. Yeah. I should keep on talking. Because we use just our base app container here and tell it, you start my foreman, this is your directory, start this worker for me, done. Whenever I want to update this worker, I just run a new git clone in it and ship it again. It's so cool. What I did for the web app itself, so I can actually access it from the outside, otherwise it stays in its Docker universe, is I had to expose, of course wrong, I had to expose a port so I can access it from the outside. So this is, where is it? I don't see it. Sorry, I don't find it. You have to expose stuff if you want to access it from the outside, otherwise it's just completely locked down. It's a closer point to stay secure. So if I now build this, I built a Docker container. The thing is, it actually didn't do anything because it's already everything did. All the commits are there. These are always the commits ID. I can always choose one of these parts and just run this part again. So in the end, we have successfully built containers. So next step, we're gonna run them. So right now, there's no single container running. It's completely empty. But you can see here my images that I created. And I have the Redis container here, I have my web app, my base app, and this is a bug in here. And I can always start them. For starting it, again, I'm a little bit lazy. I created my run script. I created my run script here. And here say, run in a detached mode, this container, and name it this. So I can always access it. You can always, when you start a container, you name it something. You make an auto-generated name so you ever find them again, otherwise you lose a container. You can access it, but you don't find it anymore. Happened. Here I link them. Here I link my Redis container, my key value store, with my worker. And this is what I showed you before, the environment variables that get exposed. This is happening there. Here I do some more to actually, this is where what I wanted to show is, this is where I can access it from the outside world. And this is a comment that you can completely ignore. So, yeah, let's run them, I would say. So they're all started, and they're all running, and they're already all able to work. So if I now try to make a request on it, I get a hash back. This is from my app. It's already in the background up and running and processing the task where it's actually sleeping right now. We're now going to attach to a Docker container that we see what's happening there. So we have these IDs that get generated. I can either use the name or can use the ID. In this case, I want to check out the web container. So I'm going to attach to this web container to see what's happening. There's not much happening because, well, it's bored. But here you see the request that just came in. Clean the keyboard and for 10 minutes or 10 times time units. We're also now going to take a look at the worker to see how that performs. So, Attaché ist nicht ganz richtig. Which one is the worker? Huh. Could be that one. Thing is, the screen is a little bit small, so I don't. Oh yeah, thank you a lot. Yes. So here I just published. No, this is my Redis.
Yeah, the 50DF.
50DF. Oh yeah. Sorry. So doing live stuff is not always so easy as it looks like. So here we have now our other the worker that is performing our tasks for us. So we tell him do our keyboard. Clean our keyboard, and our worker just is able to do 3 tasks at a time. So we're going to add now another worker. Now they start piling up and queuing up. And slowly, step by step, we get a bigger and bigger queue, and we don't want that. They're not very resource intense, but they clog our workers. So we start up a new container. Here the difference is that it's too fast. It already started. I pressed enter, it started up the whole app, and it's instantaneously started working on it. This is kind of awesome, or? Yeah. I think I'm pretty fast. Okay. Well, so what is happening here right now is I added a second container with a worker in it to my whole setup, told it, you connect to this Redis instance and start working immediately. And so it got there, pulled the first task out of there, started working or sleeping on it, and takes the next one, the next one, the next one. And now virtually could start like thousands of them, as much memory as I have, in parallel, and just work everything at once, and then kill them all again at the end. So that was the demonstration. Any questions here? So we're not just going to kill them all. Bye-bye. So Docker is awesome. It's a super cool technology. It will take a lot of overhead of your administration of you, but it also has its downsides. As I said, it's not production ready yet. They're still working on it, filing on it, making it prettier, making the APIs clean. It's rapidly changing, therefore. You should not run databases in it. We can later talk about a coffee about it. But databases have need more resources, have different approaches that they need to do their superpowers and get out of there. It does not give you security superpowers in a way. It helps you a lot in putting your app in a container where it's almost secure to break out from. It doesn't help you that you can write shitty code that people can break in. This is not, so if you use it, cool. You get an additional layer of security, but it doesn't make you invulnerable. Yeah. Genau. Last week ago, they released version 0.8. Has a few new features. You can finally use it from OS X. They started to introduce one release per month, so there will be at one point 1.0. They added new builder features, for example, that when you start up your container, you can say on build, and if you build the container, then it gets executed, so you can, on the fly, pull the fresh source code, for example. In general, they made a lot of things faster, more stable, created the registry a little bit better. As I said, brace yourselves, Docker 1.0 is coming. If they keep their promises within 2 months, it would be awesome. Cool trick on the side, you can run Docker on your remote server somewhere and let it point to your local host, and then just use on your Mac or in your Linux local host to remote control your Docker containers. Friend told me at lunch that he recently attended the security challenge, and what they did is, they shipped the containers, the challenges, in Docker containers to the people. So everything was already there. They just needed to start it up and could right away start working on it without having to download a full VM with a gigabyte of file size. You just download like a 150 megabyte container with everything in there. One thing that I want to say is Rails Summer of Code, completely not Docker related, but super important. We need help there. We need people who sponsor it. We need people who are willing to coach. We need people who are willing to answer questions and help out a little bit. If you want to help, if you want to contribute to it, it's all open source. Find this lady, talk to her. She knows all details about it. So thank you very much. If you have... Thank you. My company was so nice to give me a voucher for this conference, so if you sign up for contentful.com, you get 10% off your plan that you choose. If you have any questions, the talk will be online on my website. It's all on GitHub, Docker.io, and what I recommend you is Docker. If you go to docker.io, they have a live interactive tutorial where you can play around. It's pretty cool. This is HTML and CSS. So
thank you very much.
Welcome.